Hello everyone, I'm the first presenter Jessup Che, and let's start presentation about Lotte Tower. This is our weekly study plan. It has flow of foundation, structure, construction and scheme, and we are now studying about construction part of Lotte Tower. Last week, we studied pumping of concrete technology and also studied about tower crane and lift among lifting system. And this week, let me talk about elevator as an extension of the lifting system. In 2016, Lotte Tower, Seoul Sky, and double-deck elevator for observatory was installed. The elevator for the observatory operates a total of 496 meters from the second basement floor to the 121st floor observation deck, 55 meters higher than Burj Khalifa's layout. It is the world's longest elevator layout. In addition, the elevator has a maximum speed of 12.5 meters per second, and this section of 496 meters can be moved in just 60 seconds. Then, let's take a look at the double-deck elevator applied in Lotte Tower. A double-deck elevator is a lift that operates like a double-decker bus by connecting two lifts vertically. Transport capacity is twice that of a normal elevator, and learning efficiency is up to 1.8 times. In addition, the double-deck elevator can reduce the number of elevator layers required for the building. A double-deck elevator needs one layer per two elevators, whereas a normal elevator needs two layers per two elevators. It has the advantage of space efficiency. Also, the double-deck elevator uses traction machine from Otis. It incorporates a technology that converts heat generated during operation of an elevator into electrical energy and stores it. So this product had high energy efficiency. Since Lotte Tower pursued high-rise building and an eco-friendly building, this double-deck elevator was incorporated. Next, let's take a look at the construction method applied to the construction of this elevator. The order of installation of elevators in general high-rise building is first, frame construction of building, second, rail construction, and lastly, elevator installation. But it is a not efficient way in high-rise building. If this method is applied to Lotte Tower, it takes only a long time to install the elevator. Lotte ENC and Otis applied the segment method to solve this. The segment method is that in process of frame construction, in the middle floor, they create the temporary machine loom to pre-construct rail and exit first. Further construction of frame, they relocate temporary machine loom, and they repeat the pre-construction of rail and exit on the lower floor. The advantage of this method is first, it is much more safer in elevator construction. Second, it can save cost through acceleration of construction. Plus, for the precise construction, Lotte Tower has been installed upright by using state-of-the-art method, such as managing the verticality of the frame through application of satellite measurement. In addition, safety facilities have been applied to Lotte Tower, including this elevator.
I am the second presenter, Jo Young-jun. Let's move on to the next topic. This part is about CSPCM and CSSCM. As already explained in the structure part, Lotte Tower has a core wall. High-rise buildings also have time difference in the construction of cores and surrounding structure due to their efficient construction management. The associated methods are CSSCM and CSPCM. At this time, we'll learn about the core wall period construction method and following construction method applied to the Lotte Tower. CSPCM means core structure preceding construction method, and CSSCM means core structure succeeding construction method. Lotte Tower was constructed using the core preceding method for the lower floors and the core posting method for the higher floors. The reason for this was to ensure safety as the pyramid structure becomes narrower and narrower as it goes up. As a result, the construction period was reduced due to the increased efficiency while compensating for the shortcomings of the poorer pre-construction methods during high-rise construction. Then let's first find out about the CSPCM used in the lower floors. The process of CSPCM is as follows. First, put up the core wall, the center of the building where emergency elevators, stairs, and machine rooms are located. Then pile the surrounding floor repeatedly. It is the core wall period construction method. The main advantages of the core period construction method used in the lower layer are as follows. Because the complex activity of the core structure ends before that of the general working class, the administrator can more easily control the subsequent activity. However, there are quite a few problems with period construction methods. First, the CSPCM relies heavily on tower cranes for lifting material and equipment from rivers to portable units. This heavy reliance on tower cranes often causes delays in the total construction duration. Second, the workspace available for core structure construction becomes very limited. The construction quantities for the core areas are highly concentrated relative to the ratio of the core portion to the total floor areas. Thus, by preceding the core structure construction, the very limited workspace can cause productivity losses and safety problems such as falling accidents. Third, interference between activities is likely to occur. In the CSPCM, as the height of tall buildings increase, ACs are widely applied for the construction of vertical structure including core walls. For safety reasons, the steel operation work in the boundary area shall be stopped during the lifting of the ashes attached to the outer core wall. This leads to lost productivity. This method also leads to cost increases due to increased inputs of temporary facility such as the ACS, the temporary fire prevention and fighting system in the ACS, and temporary lift cars for core access. The increased size and height of tall buildings requires a more innovative construction method for the structure framework. Then, let's find out CSSCM. The core wall trailing construction method is constructed with the outer steel frame and the deck slab pre-constructed and the core trailing. This animation shows a cycle. Here are some examples to help you understand the course of the CSSCM. You can see the outer steel frame and the deck slab being pre-constructed and the core being followed. Usually, steel frames are constructed by combining 2 to 3 floors into one, and then When the desk slab is laid, core walls are laid under two floors. There are two things to note at CSPCM. It means that a wide working area has been secured and that organic activity management is possible with self-climbing net. It is the picture showing a self-climbing net. As you can see in this picture, steel and deck slab are constructed first, and core walls are constructed next. The following table compares the change in the construction period of the work when applying the CSSCM and CSPCM compared through one experiment. As a result, we can see that CSSCM has enabled significant construction period reduction compared to CSPCM. After the construction of the surrounding steel structure and deck slab, the cotton wall is installed after the concrete is laid on the slab and core wall. Next week, we will study about cotton wall. This is the role of our team members. Thank you for listening.